Welcome to Calculus.
Our stress tolerance level has risen so high that nothing phases us.
On this episode, Stevenson will demonstrate
Now that we've been talking so much about concept and definitions, vocabulary, let's actually apply what we've been doing here. So you're going to notice I have my calculator handy, so make sure you grab yours. Here's the problem. Find the absolute extrema of f of x equals x to the power of 2/3 on the closed interval from -2 to 3. So the first thing we want to do is figure out if extreme value theorem applies. So what does this look like? We need to make sure we know what it looks like to help us understand if it's continuous. Because remember, for extreme value theorem to apply, it must be continuous on a closed interval. Well, if we have a closed interval, so that requirement's met, but we have to make sure it's continuous on this closed interval. Well, what this really is the cube root of x quantity squared. So the cube root of x is that s-looking function, okay? But because it's squared, it moves, it reflects up. So it's going to look like that. The difference, though, here is that the interval's from -2 to 3. So -2 is here, and then 3 will be here. So the difference is that one part's going to be a little bit higher than the other. Something like that. Okay? So, in the grand scheme of things, does extreme value theorem apply? Yes, it does. I know it applies because I have a continuous function on a closed interval. Now, it's not differentiable at 0, but we don't need that yet. So just sit tight for that. Extreme value theorem applies. The next thing we have to do is find the derivative. Now you may be wondering, why did I rewrite my derivative like this? Well, I did power rule here, right? But I rewrote it like this because in my next step, I have to kind of do some thinking and figure out when this equals certain values or where it's undefined. So by having it in this form, it'll be easier for me to process. Here's what I mean. The next step is to find our critical points. So let's start here. When does the derivative equal 0? Well, I would set this equation equal to 0 and solve. But hopefully, mentally, as you see, if I set this equal to 0 and solve, I'm not going to get an answer. It doesn't exist. So what that means is there are no values that will make the derivative equal to 0. So we're going to say none. Now let's look and see, when does the derivative not exist? Okay, so this is asking you for domain restrictions on this derivative here. What's the only number I can't put into this function? This is my derivative. What's the only thing I can't put in? Well, I can't put in 0. So that is when the derivative does not exist. In this particular problem here, I only have one critical point. So now that I've found my critical points, I know my derivative, I have my interval, we're going to make a table of values. The table of values is going to help me figure out what is my absolute maximum, what is my absolute minimum. Because remember, extreme value theorem applies. What that means is I am guaranteed both an absolute max and an absolute minimum. When you make your table, you're representing your function. So your x values are going to be your endpoints and any critical points you find. So list them numerically. So -2, then 0, then 3. Now what I'm going to do is evaluate my f of x, which is the original problem up here, at these values. Lastly, we look at our table here and we can see that our absolute maximum will be 3 to the 2/3 power when x is 3. My absolute minimum will be 0 when x is 0. Notice I didn't say my decimal. I left it in exact form because in this case I can. There may be times where you may have to put the decimal and that's okay. Just remember to be accurate to 3 place values. Let's write our sentence. So when you write your sentence, you want to say, what is the function? What does it have? What it is? When it happens. In this particular problem, it didn't specify if it wanted just the extrema, like when it happened or what it was. So I'm going to list both. So let's look at a possible sentence frame to help us out here. thing. Now, this is a very rough sentence frame, but you can modify this as needed. But this may help you with your work.